from the Computer Science and Engineering Department, and she will tell us about uh, various word processing techniques and so on. So in the last class we learned about the sentiment analysis and other applications of text mining, text analytics in the domain of economics. So we saw that these techniques or these approaches are useful, but how exactly to do them, that we have not seen. So hopefully in today's lecture by Professor Sarkar and in the next three lectures in the upcoming week, we will understand a bit more about how what kinds of tools and techniques are there in these domains, which will enable us to do the tasks such as sentiment analysis and so on, which are necessary for economic applications. So I request Professor Sarkar to take over.
Thank you, Abday. Actually, I'm not familiar with what they have done in the last class. So, I have prepared the lectures in a sort of overview way. So please feel free to interrupt and then we can discuss whatever we wish to once I get started and we can lead the discussion in whatever way you will like to. So the topic of today's lecture is to look at, why the use of language processing is useful for different studies that economists do and in different in applications related to economics, finance, and so on. Now, as you may know, natural language processing involves building computational systems that can analyze and understand human language or generate natural language. And it enables computer systems to communicate with people. And NLP has become very popular as a research methodology in various domains, including the domain of various social sciences and economics. And the reason is not far to seek. The majority of the data is there in unstructured form. They are not there in tables. And if one can get information or knowledge from these sources, that will help in various domains of application. So the important skills that are used by NLP are the way of interacting with the world using natural language, and conversational agents are being used in a large number of domains, whether it is banking or retail or others. Then one can use NLP to have computers read the text which is there, which contains textual data, and retrieve information that you require, answer your questions, summarize or aggregate information, and maybe find new insights and intelligence from such analysis. Now, NLP tools can empower people who work with economics in various ways. For example, as I mentioned, one of the most important things is that you can make use of textual data, different types of textual data, such as user reviews, employee evaluation, surveys, news documents, research reports, and so on. And based on such tools, one can even predict unobserved outcomes and do some sort of counterfactual analysis. One can identify what is the most relevant data to collect and so on. But there are various challenges in making use of natural language processing. These are general challenges with natural language. Firstly, language is ambiguous, and there's ambiguity at various levels. A word can have multiple meanings. A sentence can be parsed in multiple ways. The syntactic structure is not unique given a sentence. The meanings, a same sentence can be interpreted in different ways. The referential ambiguity, whether two objects, they refer to each other, or which pronoun refers to which object. So there's a lot of ambiguity there. Then people use non-literal language and so on. There's a lot of richness in language because the same thought can be expressed in so many different ways. Then there is linguistic diversity because there are so many languages. In a language, there are so many dialects, and there are various genres, whether it is a book genre or writing a blog, or you have a message, or you are complaining, the type of language used may be very different. Also, to understand textual data, it requires world knowledge, it requires common sense knowledge and reasoning. Now, these are certain NLP-driven applications which have been used in different domains. Search, that is retrieval of documents given your query, translation from one language to another, chatbots or conversational systems, question answering systems, summarization, analyzing the sentiment in a particular review or some text, extracting of topic, identifying the entities of interest from a text document, identifying relations between different entities, monitoring social media, and so on. And many of these tasks are also relevant in the domain of economics and finance. So, for example, if you look at the banking sector, these are just some of the use cases for use of NLP in banking: analysis of investment, for example, getting insights, analyzing sentiments, servicing customers through chatbots, analytics of customers, then document search for various requirements. Now, in order to enable this, a variety of text processing methods have been used, starting from the classical NLP, where you use regular expressions to incorporate patterns based on which you can extract information from data. You may have to collect corpus or collection of documents, and you may annotate them if you want to use data-driven methods of making inferences. One can do exploratory analysis of corpus to understand the corpus, how it is structured, what is the distribution, what type of topics are there. One can do classify text based on a known set of labels, extract information from documents, such as identify entities, identify relations, find topics in a large corpus, summarize, and so on. So please let me know if you have any questions. And these are some other tools, text recommendation, text to speech or speech to text, if you want to communicate with spoken language generation, and so on. So this is an example of a text classification system. So you may have documents and you want to identify documents belonging to a specific topic, or given a set of topics, you want to automatically classify the document. For example, suppose you want to monitor the news and you want to find out those news which are relevant for predicting the values of stock. So you want to classify a news document as relevant or not. So you can have a classifier which takes the document and classifies it as relevant or not relevant. In information extraction, you have some passage or a document and you want to extract specific information from that document. For example, suppose this is a document which is given to you. S3, and then from reading this document, you have to find the answer. So in order to find the answer in a classical way, you have to identify what are the named entities in the document, link the different mentions of the same entity, extract relations. For example, this says Luca Mestri, Apple's finance chief. So you have to identify that Luca Mestri is a name of a person entity, Apple is a name of a company or an organization, finance chief is a role or role in the company, and based on this you can try to answer this question. Of course, there are other data-driven methods to answer these questions also. Then this is an example of a system. If you ask such a question in Google, where was Albert Einstein born, you will straight away get the answer. So in Google, several questions, they're called open domain questions. You can get the answers. In order to derive that answer, one has to identify the system. The underlying system has to extract named entities and link them. And identify that's Ulm, Germany, find out where Ulm, Germany is. So this is a map location of this place, and this is a photo of the place. Then in various topics, when a document comprises of a sequence of words, but sometimes you also have multiple words which together have certain meaning. So you want to identify not only the words, but also the phrases which are important for your task. And also you want to find out different documents that include some of these phrases. Then this is an example of event relation extraction. So for example, if you read this text, let us say, accepted to MIT, no words can describe how happy I am, etc. From this, your information extraction system may be able to identify that the event type is university admission and the event property, that the name of the university is MIT, and so on. This is a schematic diagram of a conversational agent or a chatbot, and you can have an interface of the chatbot based on text or based on a human user who speaks. So these are the different modules of a chatbot. For example, you have the language understanding module. First, if you use a spoken chatbot, you have to do speech recognition. Then there is language understanding, which involves identifying the domain of what the user is talking about, intent in the domain. Suppose you find out that the domain is a banking domain. The intent is to withdraw money, and the slot filling means you have to find out the values of various fields. Suppose I want to withdraw 5,000 rupees from my savings account ending in 6460. So these are the things that will be done based by the natural language understanding module. Then there is a dialogue management module, which will keep track of the state of the system, and it will recommend what is the output that the system should produce. Based on that, the message generator will take that output and it will convert it into a natural language sentence by a natural language generation module. And this dialogue management module will interact with an application database in order to retrieve the answer or a collection of text data or a corpus. And as I said, the interface can also be spoken. This is an example of search, question answering, etc. Now, this is one of the topics where I will spend a little bit of time, because this is also extensively used by economists. This is topic modeling. Given a corpus, which is not labeled, not annotated, you want to understand what the corpus is about and identify what are the major themes covered in the collection of documents. So this is called topic modeling. For example, based on this corpus, one can identify each column represents a vector for a topic. I will talk a little bit detail about it subsequently. So one has identified that these are 4 major themes in the document, and these themes are described by the collection of words. This word genetics has been put by a human by looking at these words, that this is a theme of genetics, this is the theme of evolution, this is a theme of disease, this is a theme of computers, and so on. Now, as I said, language is a very important means of communication, and for economists, it's NLP important. There's a lot of research and news which is published in the form of text, and the information that is extracted from text can complement the numerical data or the tabular data that economists have available for their research. Now, certain difficulties in extracting with text is that text is inherently high dimensional. Of course, it depends on what are the units in which you decompose text. Usually, the units of text are the words or the tokens. Now, the number of words or tokens in a language is quite large, maybe of the order of 100,000 or so. And then there are other complexities. For example, the same root word can be inflected for different grammatical attributes. For example, singular, plural, or different verb tense and so on. So the total number of tokens can be very large. And if you have a document which contains a number of tokens, how can you represent such a high dimensional data? How is raw text represented? And based on this representation, one has to develop the models that predict or describe or do causal analysis. One of the simplest models of representing data, so if you want to represent a document, let us say, you first come up with a representation of words, and based on the representation of words, you can have a representation of document. Suppose you have a corpus belonging to a particular language, and in this corpus, there are V unique tokens. So to represent a word, you can consider a vector whose dimension is V, and you can, if there are V words, you can assign each word an index I. I is between 1 and V. So you can build a dictionary where if the first word, second word, third word, fourth word, etc. And in order to represent the ith word, you have a vector where the ith position is 1 and the rest of the position is 0. This is called a one-hot representation of word. You can also have a representation of a document based on this type of representation. So can you suggest how we can represent a document? Suppose a document contains 500 words. How can we represent a document as a vector? Suppose we have V words in our vocabulary. Our document contains a sequence of words taken from this vocabulary or this dictionary. So can you suggest how we can compactly represent a document using a vector? Yes, please. You can just think aloud. Vaibhav, do you have any suggestion?
Ma'am, if we use one-hot encoding, then the size would be very large. So we may go on to use word embeddings of sort.
Right. So you can, but let us assume that we are going to use one-hot embedding, right? So that represent a word. In this paradigm, how do we represent a document? So at least tell me your thoughts. Suppose we want to represent a document by a vector of size V. Okay. Suppose we want to represent a document by a vector of size V. So to represent a word, we only put 1 in the ith position, 0 in the rest of the position. But a document contains multiple words. So how can we represent a document as a vector of size V?
We'll have the count of words in that respective position.
Right. So good. That is definitely one option, a good option. So we look at every word. So let us look at the ith word. We find out that it is present 3 times. we find the 15th word, it is present 2 times, another word is present 0 times. So we can represent a document by a vector of counts of the words. Now, can you tell me what is a disadvantage or what is a limitation of this method?
A big document, like a big document may contain like the many times. Let's say the word the many times, whereas a small document may contain it less frequently. So we may divide it by the maximum frequency of the
Yes.
of any word.
Okay, so we can normalize it. Let us say we can normalize it by the length of the document in some way. Okay, but if we represent the number of words which occur in the document only, what is it that we are losing?
Now we won't be able to quantify the rare words. The words.
Rare word, if it is part of the vocabulary, it will be 0 or 1 or 2.
Yes, ma'am. But I remember that we include some epsilon value in the count variable.
So that is called smoothing. So let us not worry about it. We are not, that is not relevant here. We have a specific document that contains some words. Even a frequent word may or may not be in this document. A rare word may or may not be. So the total document has 500 words. Your vocabulary is of size 100,000. So some words are there once, some words are there 10 times. Most of the words are not there. Okay. And you may do some normalization. You may do some normalization to take care of whether a word like the occurs in almost all documents and another word like vector only occurs in some of the documents. So for that, we look at not only the term frequency, but also the document frequency. How many documents contains this word and take inverse of that. That is called IDF, TF, IDF. Based on TF, IDF, we can compose the vector. So there are various small things there. Well, let's not get into it. But can you tell me what is it that we are losing out on by representing a document as a vector?
Meaning maybe like two sentences may have same words but different meanings.
I'm not only looking at the set of words, but the meaning of a sentence or a document comes from the sequence of words, right? So I spoke to you and you spoke to, Vidyut spoke to Tushar and Tushar spoke to Vidyut. These have two different meanings, but they contain the same set of words. So the meanings are lost. Okay? Nevertheless, this is useful for tasks such as text classification, but not useful for tasks which involve finding meaning from the document. Now, as some of you were trying to hint at, so this is one model. In recent times, people have also tried to represent words in terms of lower dimensional vectors. So instead of one-hot vectors, these are called dense embedding. So let us say typically the word vector size will be 300 or 500 or 100, and it will be a 300 dimensional vector, and each position can have a numerical, can have some numerical value, right? And such representations of such words as vectors can be learned based on basic machine learning, where you pose the task of trying to find out the vector of a central word from the vector of the surrounding words. Or the other task of, given the central word, you try to find the surrounding words. Based on that, one can set up a machine learning task and try to learn the vectors of these different words. So this is called, this type of representation is called word-to-vec representation, and they give us low dimensional dense embedding of words. Now this type of embedding, apart from it that the vector size is small, the main advantage is that if such embeddings are learned from a very large corpus, similar words will have similar vectors. So in natural language, words are related to each other. Some words are synonyms, some are Some belong to the same group, some are opposites, and so on. So if you look at two words in the one-hot representation, the two words are taken as completely independent. But if the words have some similarity or some relation between each other, that is not captured in one-hot embedding. But such word-to-vec representations have been shown to capture such relations, because there is a saying that a word is known by the company it keeps. So if word 1 and word 2 have similar contexts, then there's similarity between the words, and this is captured by this representation. And this is one of the powerful, ideas in NLP, which has pushed the limits of natural language processing. And more recently, there have been even more progress in this direction by looking at contextualized word vector. Now, a word can have different meanings based on the context where it is used. Suppose you take the word bank, it can have multiple meanings. Now, so if you have a fixed vector for the word bank, then you are not distinguishing between its context. So there have been some powerful models. For example, the model called BERT, which is based on a neural network model called transformers, that can take a piece of text, a sequence of words, and come up with a representation which is contextual on the entire text. It's not only word specific. And the use of such models, and then there is another type of model like GPT. We'll not go into the details of this model by OpenAI. The BERT is from the group in Google. So they are different pre-trained models of contextual representation, and they led, so this type of representation has given rise to significant improvements in various NLP tasks. So the representations, and especially these modern representations, have played a major role in making NLP systems more effective. So these are called pre-trained language models, where instead of training the model from scratch, you can use another pre-trained model based on the corpus, and then using that representation, you can fine-tune the parameters of the model to solve a specific NLP task. Now, I will just talk about certain domains in economics or related domains where NLP can be used. So one is stock market analytics. For example, predicting the economic performance indicators by analyzing different textual documents. Product analytics based on social media monitoring, news monitoring, summarization of reviews, and so on. Customer analytics to profile customers, organization analytics, and so on. Then analysis of macroeconomic phenomena based on NLP, finding market sentiments and emotions, finding relationships between the quantitative or structured economic data and the qualitative economic data obtained from different textual sources, managing of information, and so on, identifying fake information, chatbots, and so on. So these are some of the applications. So these are some specific use cases that people have worked on. So use Google search data to estimate the racial animus of a particular local area, and then study the causal effect of the racial animus on votes by different parties. Using news text to estimate each news outlet's bias, then measuring local news coverage of earnings announcements, and so on. Now, as I told, that the sources of data that are useful for economists can come from various sources. For example, news articles, social media posts, research articles, quarterly earnings documents, web searches, company disclosures, and patents. And to summarize, we can say that there are many use cases of NLP methods in various branches of economics. There are a lot of sources of text from tweets to bank documents which can be used for the analysis. And various NLP approaches have been tried. These methods can be used. Typically, the methods from this textual data has been used to find correlations between different variables. People are also trying to understand causal inferences from these variables using various methods in causal inferencing. So with this, I will pause for a minute, and if you have some basic questions, then we can discuss. Then we will talk a little bit about some NLP modules and especially topic modeling. Any questions? So let us look at, so if you are trying to do some text mining on some natural language data, let us look at some of the steps that one has to perform. So you take a text in natural language. This is called unstructured text. This is the initial text corpus. So you prepare the text by pre-processing. For example, identifying the tokens, from the tokens, maybe, analyzing the tokens, getting the root words or stemming if you require it, maybe doing some parsing and so on. And then you want to convert it into some structured information. For example, by analyzing the text corpus. So you try to get some information. And one can then do analysis on the structured data. These are some related terminologies that you might come across. We have already mentioned some of them. A corpus is a collection of documents. Now, if you look at the words, if you look at the vectors, as some of you mentioned, there are certain words which are function words, which do not tell you about the topic. Suppose you want to do text classification, a word like the does not contribute to the meaning of the document because this word occurs in almost all documents, or rather all documents. So the words such as articles, prepositions, conjunctions, etc., or those words which are frequent can be removed. You cannot remove them if you're trying to do syntactic analysis, but for the process of understanding the textual content, you can remove them. So they are called stop words. Then there's the process of tokenizing, which is you take a document or a sequence of text and you break it up into tokens. A token can be a word, can be a multi-word phrase, can be a symbol like a punctuation, or it can be a part of a word, depending on what type of analysis you are doing. And for certain type of analysis, you may like, for example, if you're doing the text search in the simplest way, you can convert a document to a vector in a way which I have told. That for that, what you can do is that you can have a term document matrix. So where the term is all the words which are there in the vocabulary, and each document you write down the number of times the term occurs in the document. This is called a term document matrix. This is the basic term document matrix. You can augment it by normalizing it or by adding, multiplying with the IDF, etc. Sometimes, as we said that if your vocabulary, if you're in many languages, the same root word, the same dictionary word can take various forms. For example, in Bengali, if you have a particular verb, there can be more than 100 inflections of verb for various tenses, tense, aspect, and modality. Right? Then if you take a noun, the noun may be inflected for singular for number, in some languages for gender, in some languages based on its case, whether it is a subject or object and so on. So stemming means take the word and find its root, and you may also try to find out based on the overall form what is the function of the word. Now, in various cases, this information retrieval is very useful, where you have a collection of documents and you have a requirement which you formulate through a query. Given the query, you want to retrieve the documents which contain which are the relevant for your query. So this is a very schematic diagram of an information retrieval system where you have the different documents comprising your corpora, and so you want to this is the collection of documents. You annotate it, normalize the document, prepare this document and build it into a data structure so that when the user gives a query, from the query you can extract those documents which contain those information. So in order to create this database, different data structures are used, and indexing is important, where the index terms are the words or the phrases, so that given a particular index term, you can find out the list of document where the index term occurs. A query may have a sequence of such index terms, and the objective of an IR system is, given a query, which is a sequence of words, you want to retrieve the documents. So ad hoc retrieval is just trying to retrieve the documents. There are also different other use cases of information retrieval, such as filtering. Filtering means if you have a particular domain of interest and you have a source of textual data, filtering or sorting will identify those documents which are relevant for you and only route them, and the rest will be discarded. Also used for browsing or navigation. Now, we will talk about, topic modeling is a theme that many researchers in economics work at. So the idea of topic modeling is to take a corpus and identify the latent themes or topics. And if you want to do topic modeling, some pre-processing is usually done. You take a base corpus, you clean the corpus. There are various, we have already talked about stemming, removing stop word, you can remove numbers, punctuations, etc. And maybe case folding to convert all the words to lowercase. From that, you can generate the term document matrix, right? Now, why topic modeling? So today we have a lot of information, and because there's a lot of information, there's an information overload. It is difficult to find what we need. So if you want to discover the main themes that pervade a large collection of documents, one can use topic modeling. One of the basic methods of topic modeling is called latent Dirichlet allocation, though there are various other types of topic modeling which use more sophisticated technique, but basic LDA is still very useful. This is a technique based on Bayesian modeling, where you take a collection of documents and the term document matrix which you have composed, and from that you try to identify the topics in an unsupervised manner. So these topics are represented by a vector, by a collection of words and the scores of these words in that topic. So topics are these vectors. They need not be meaningful, but looking at the words, you can get a sense of what this theme means. So topic models can be applied to large collections of documents, and it helps to understand the collection and summarize them. So as I said, LDA is the most popular and one of the earliest topic modeling algorithm. I will not go into the exact mathematics of LDA for this class, But to give you a high-level idea, we consider that each document is a mixture of topics, and each topic is characterized by some set of keywords related to the topic. So a keyword can exist in multiple topics with different degrees of importance. So a topic is a collection of keywords, and there are different scores associated with this keyword. So it is a vector of these words. A topic is a vector of these words, and a document is a mixture of topics. And a document can have multiple topics, but they are mixed. You know, some topics are more important in that document and some are less important. So this is the underlying model that we look at. So, so given this collection of documents, so these are different documents. And then, so what, by doing such sort of topic modeling, you will come up with topics. And this is an example of a topic, gene, DNA, generic. And so these are different keywords. And for each keyword, you have a score or the vector coefficient. Okay. So this is life, evolve, organize. The same word, say, let's say life may occur in this vector as well as this vector, but the scores may be different. So a topic is a vector. And a document is a mixture of topics. So there is this 4 topics, let us say you have a topic model, there are 4 topics, and it shows that this document has 3 of these topics. So the red topic, you know, so the size of the bar tells you how much prominent this topic is in this particular document. So a topic is a distribution of words, and each document is a mixture of topics, and each word is drawn from one of those topics. So in the parlance of this type of word, this is called a generative model. There you assume a model of how these documents were generated, and based on that you try to find this out. Now, without going into the mathematics of LDA, let us show a typical output when you use an LDA as a tool. So when you apply LDA on a collection of documents, so this shows, this is a generic example, which is taken from, I think, Zurawski and Martin book, where LDA was applied on 17,000 science articles, and the number of topics were set to be 100. And you know, so you got 100 topics, and here we are showing 4 of those topics. So for topic 1, this is the vector, right? And if you go through the words, this term genetics is just given by the user. This has not come from the topic model. And given a topic, you can find out what is the distribution of words, and a document as a distribution of topics. Now, there are various applications of topic models. You can analyze the topics over time, that is temporal analysis. If you look at the mentions of different topics, as you look at news over time, you can see which topics are getting more prominent, which are losing prominence. You can analyze topics by author, like which author is, which author's work incorporate what type of topics. You can find out similar documents based on the topics that they cover. So topic models have been used for annotating documents, organizing and browsing large corpora, model, as I already told, model topic evolution over time, and so on. So we take a specific example from this paper where they use topic modeling to profile underground economy sellers. So this paper is called Identifying and Profiling Key Sellers in Cybercarding Community, etc. So just to go through this use case. So the underground economy is the online black market for exchanging products, services that relate to cyber crimes. So the sellers, they advertise their products by giving details about their resources, payments, contacts, etc. And the objective of this work was to profile the underground economy sellers to reflect their characteristics. So the input to this topic modeling was the original threads from the hacker forums, and they were pre-processed to identify threads related to the underground economy by conducting snowball sampling based keyword search. That is some sort of crowdsourcing where you try to get these things, and you incorporate other users to do the same, other friends who do the same. By this, these threads were collected, and the threads were classified using a text classification method. So you identify which are the advertisement threads. So you focus on malware advertisements and stolen card advertisements. For this paper, it can also be generalized to other advertisements. So this is a schematic diagram. There's a HackerWeb forum collection. They put certain keywords which are likely to be used by the black market, retrieve the threads through this crowdsourcing and identifying new keywords, so some sort of bootstrapping, find the relevant threads, classify threads by identifying the features and using a Maxent classifier. Maxent classifier is a type of text classification based on the principle of maximum entropy. Then you identify, two types of threads, malware threads and stolen card threads, and those which do not belong to either of them, which you discard. And then this is the analytics module where you try to do sentiment analysis of these threads, and then to find out the rating of the sellers, and then you try to profile the sellers by topic model. So for example, this shows up at one example input from rescatter.cm. So you find out these data sources and use it for your topic model. Then so when you run, so these models are also available as tools, and you can configure. When you run them, you have to give certain arguments. For example, you have to give the number of topics, and then you choose your parameters based on the perplexity, which is a score. Will not get into it now. So, but after running this, the LDA will give you the probabilities of each topic associated with the seller, and you pick. So from the entire collection, you get all the topics, and for each seller, you find out the top K topics, and for each topic, you pick the top J keywords to have an user understanding, human understanding of the topic. For example, this method applied to Rescatter, gives you the these topics, and the keywords for those topics are given. There's 5 topics. The first topic, the keywords are shop, WMZ, ICQ, web money, price, dump, and so on. The fourth one is dollars, stamps, deposit payment, sell, online, verified, and so on. And these can be interpreted that this first topic is product, credit cards, products. The second one is payment. Then this is contact, and so on. Then there are various tools for topic modeling. Some of them are shown here. The Gensim tool in Python. Then sklearn also has implementation of LDA and various other things. There are also some online sites where you can feed your documents and they will give you a topic model and one can explore. So there are various other tools that one can use for different other, topics in NLP, which are very important, useful for the economics domain. For example, information extraction. I did not go into the details, and they can be based on rules such as regular expressions or patterns, or there are, if you can collect and annotate data, you can use different machine learning based information extraction systems. So with this, I stop today. So if you have any questions, then we can discuss.
Okay, if there are no further questions, then we can thank Professor Shorkar for the for her insightful lecture.